Okay, as I had explained, this is you need to go to your extended notes, and this is the first page, and we are doing something called as piecewise functions. Piecewise function is when within the same graph you have basically different kinds of equations, and you'll see that soon. But let's go ahead and write down the definition first. A function, so piecewise function is a function which has different equation for different parts of its domain. We know what domain is. We have talked about this. Domain is nothing but your x values. So look at this. So for example, one of the graphs that you know of is absolute value. So let's write that down. The absolute value function, and you'll see why. Is an example of a piecewise function. Why is that? You see how this is how a piecewise function looks like. But at x equals to 0, when we take this is where the graph changes. All values of x greater than 0, you'll see how this has both are linear, but this is a linear with a positive slope, and this is a linear function with a negative slope. So they actually have different equations. So this is how you write your absolute value. You put like a little curly thing and write all your domain. So for x less than 0, that means you're talking about this section. It's basically it's y equals to negative x. Basically your linear equation y equals to mx plus b. B is 0, slope is 1, but it's negative 1 in this case. So that's the equation of the line, this line, y equals to negative x. And the equation of this line for x greater than equal to 0, there should be no gap, this is less than, this is greater than equal to 0, is y equals to x. Mx plus b, and it's a positive slope, it's y equals to x. So this is a example of a piecewise function. Okay, so let's look at let's go down and see what else is going on here with the piecewise function. You see how it says, it tells you to evaluate, but let's look at this. I want you to look at this piecewise function, how it's written. Look at this piecewise function. It says f of x function, when x is less than 2, it has one equation. When x is greater than equal to 2, it has another equation. This happens in real life. Piecewise function definitely happens in real life. It's like saying that if you go to a bank to deposit some money, if you deposit $500, your interest is calculated as, I don't know, maybe 5% of what you invest. And then if you invest more than $500, it's calculated as 6%. So two different equations depending on what the input is, how much money you're investing. So I'm just giving you an example, but this is used a lot. So for us to evaluate, how do you evaluate a function given? When x equals to 0, you would normally just substitute it. But there are two equations. Where would you substitute it? X equals to 0. That means this. If I call this equation 1, I would substitute in equation 1 because 0 is less than 2. So x plus 2, 2 plus 0 is just 2. X equals to 2. Okay, this is tricky because both of them say 2, but this is the one that's greater than equal to 2. So you will substitute here. 2 times 2 is 4 plus 1 is 5. So this I'm using equation 2. This I'm using equation 1. And let's look at this. X equals to 4, definitely here, right? So go ahead and calculate. 4 times 2 plus 1 is 9. So here I'm again using equation 2. Alright, this is your evaluating it. And let's look at how do you actually graph it. How do you actually graph it? So this is my piecewise function. And the way I graph it is, it will vary, my equation will vary depending on if x is greater than equal to 1 and x is greater than 1. Sorry, x is less than equal to 1 and x is greater than 1. So what we do is, instead of just graphing it as a line, because I know both of them are linear, if I graph it as a line, I don't know where to stop and where to end, how it goes, right? So what I actually do is I create two tables. This table 1 is for equation 1 and this table 2 is for equation 2. So what we do is, the first one, y equals to 2x minus 1. What are the x values you will take? You will take the x values where x is less than 1. Where x is less than 1. So let's start with 1 and x is 1. And what do you notice here? X is less than equal to 1, right? You see that? So what you're going to do is you're going to put in a closed circle. Remember we talked about open and closed circle. If it's a closed circle, that means you're including 1. When x equals to 1, this is going to be 1. Let's take 0. When x equals to 0, 2 times 0, so that's negative 1. You're going down, right? Because x less than, and then I'll take negative 1. When x equals to negative 1, go ahead and substitute. You should see negative 3. And when x equals to I'm going with one more value, -2, -5. Okay, so hopefully, and then you can keep going for multiple numbers, but then you have to stop at some point. You can definitely draw a linear equation with these 4 points. And then equation 2. So let's look at equation 2. So equation 2 is basically table 2, all values of x greater than 1. Okay, should I take 1? It says greater than 1. This one says less than equal to, so I took 1. But this one says greater than 1. Should I take 1 or should I take 2? You should take 1. You know why? Because it includes all values even slightly above 1. A greater than 1 basically 1.1, 1.2, but how are you going to do that? So what you do is you take 1, but next to 1 you put an open circle. And I'll tell you when we actually graph it. As to how it's going to look like. Okay, I was just looking at some stuff. Okay, so when it's equal to 1, you're going to substitute this in, so 3 times 1, so that's 4. And then when it is, why don't you guys hit pause, go ahead and fill up these values. So all you're doing is taking values greater than 1 and filling it up, and hopefully you hit pause and then you come back. When it's 2, it's 7, when it's 3, it's 10, when it's 4, it's 4. Okay, now it's time for you to graph this. And then we will do the domain and range. So how do you graph this? So basically we will graph equation 1. So when x equals to 1, y equals to 1, and I'm going to put a closed circle. When x equals to 0, y equals to, when x equals to 0, y equals to -1. When x equals to -1, y equals to -3. -1, -2, -3. When x equals to -2, y equals to -5. 1, 2, 3, 4, 5. There. I see that is a straight line. I should actually use a ruler, but you can draw a straight line. And this is an open circle. So this is your equation 1. Okay, let's do equation 2. Equation 2 is when x equals to 1, y equals to 4, x equals to 1, y equals to 4, 1, 2, 3, 4, and it is an open circle. When x equals to 2, 1, 2, it's 1, 2, 3, 4, 5, 6, 7. And then next x equals to 3, now it's kind of going outside. So 1, 2, 3, this was 7, 8, 9, right here. And then it goes on forever, and then I'm going to draw my, this is how your piecewise function looks like. This is equation 2. This is how your piecewise function looks like. It's normally generally it's like a broken, so but the dividing thing is where it changes is this one. Domain change happens at x equals to 1. X equals to less than equal to 1, it goes this way. When x is greater than 1, it uses this equation. So you can see at what x value this is changing. Okay, let's keep going. That's the next page. So what I'd like you to do is I'd like you to hit pause for any one of these and go ahead and see how this works, but I will go ahead and talk through it, and the rest of the so for now let's look at 3. Let's go look at 3. Go ahead and please hit pause and go ahead and create the 2 tables and compare your 2 tables. So this is table 1, and then I want to create table 2 maybe here. So this is equation 1, equation 2. Let me just quickly talk about equation 1. This is x. What are the x values I'll take? All values of x less than 1, right? So I will start with 1. You do have to take 1, and 1 will be an open circle, and I'll go down from 1, I go to 0, and then I go to -1. Please calculate the y values. Please do that for this x also. This is all x greater than equal to 1. So 1, I'll take 1, 2, and 3. Okay, and I'm going to continue filling in the values. You hit pause, you can do the calculation, see if you get this. I got 1 for this. And this is a closed circle. Please don't forget that, because when you're drawing the graph you may forget, so it's good to keep it right here. Okay, now I'm going to go ahead and graph it. I'll first graph equation 1. Equation 1, when x equals to 1, y equals to 1, and it's an open circle. And then when x equals to 0, y equals to, did I do it correct? No. 1, yeah. No, sorry, this is, I'm so sorry, hold on 1 second. -1, no, I think I got it wrong. -1 is 1, 0, and +1 is 2, right? So because I'm going from 1, 0, and -1, and this becomes an open circle. Sorry, I think I wrote it wrong. Sorry, here we go. And then what happens? When I take 1, when x equals to, yeah, here we go. Okay, I was doing the calculation, I wrote it down somewhere else, I just copied it wrong. So -1 is 1, 0 is 3/2, 1 is 2, and 1 has an open circle. When x equals to 1, y equals to 2, so it's not this, it's this, and it's an open circle. So that point does not exist. I'm really sorry for causing this confusion, but hopefully you did it right and you got what I'm talking about. Okay, when x equals to 0, it's 3/2. When x equals to -1, it is 1. There I go, that's my straight line. And then let's look at equation 2, and this is your y. When x equals to 1, y is also equal to, it's the same value. When x equals to 1, it's the same value, and this is a closed circle. Closed circles will override the open circle. When x equals to 2, it's 1. When x equals to 3, it's 0, and this is my second line. So these are my two equations, and again at x equals to 1, it's where it changes the equation changes. The equation changes. Okay, let's go ahead and do the next one. Next one is a little different. Oh yes, we forgot to. I don't know if the previous one it asked for domain and range, but I did forget to write that. But let's go ahead and I'm sorry. I want to flip the paper back. I think you guys can also go back. Please go to the previous one, and let's go ahead and write the domain and range. So let's go ahead. Domain and range is easier to write after you see the graph. So here my domain is your x value, so it goes on forever in this direction. Keeps going. And then it looks like it stops at 1. But 1, there is value. The second equation picks up right after this 1. There's no gap on the domain because it stops here, x equals to 1, and the second equation picks up at x equals to 1.1 or whatever that is, and it keeps going. So it is -infinity to positive. And then let's look at this range. It goes on. Let's start from the bottom right. It's going on forever. And then all the values are included, and I actually go only up to 1. And then looks like there's a break. Whenever you have to write to range, you will put a union, and you will stop here and then pick it up from here. And where do you pick up? This is 1, 2, 3, 4. You'll pick up at 4 and go to 1. That's how you will write the range for this particular piecewise function. All right, let's go to the next page. That's where we were. Let's write the domain and range for that. Domain is easy to see. All values are covered. And range is -infinity, and it stops at 2. Wait, 1, 2. Yeah. Okay. I will stop this video, and we will come back again, and I can make another video so that we can take a break on this video, and we can start another video.